Hey guys, welcome to part 2 of problem set 117. This is just a continuation from yesterday. I'm going to remind you how we actually pronounce this in English. So these curly braces tell me that this is a set. So I would say the set where x is an element of the integers such that x plus 3 is greater than 5. So all we really need to do is graph this portion, x plus 3 is greater than 5, and just remember that our domain is integers. So in order to graph this, we need to isolate x. So I'm going to move my 3 to the other side and say x is greater than 2. And then what we're going to do is graph it. Now, knowing that I've got integers and I don't have a equal bar here, I can't put a dot on 2, but I can put a dot on any other integer afterwards. And we have our graph. Okay, let's have you guys try one. I'm going to give you guys 60 seconds to do this. Unpause your video to see the solution. Okay, so just like last time, we have a set. We would read this a little bit different because we actually have a variable assigned to our set. So we would just say A is the set where x is an element of the integers such that x plus 1 is greater than 1. And just like before, I'm graphing this portion and my domain is integers. That's what this part tells me. So I'm going to isolate x here. So that tells me x is greater than 0. And then I'm just going to graph that on my number line. Because there's no equal bar, I can't put a dot on 0, but I can put a dot on any other integer after that. For those of you who got that right, really good job. Let's try one last type of these. This is one of those where I'm going to be factoring and get a product that's less than 0. So try to remember how to do that. I'm going to give you guys 70 seconds to try this. Unpause your video to remind yourself how this is accomplished. Okay, so we're graphing this portion of it, and my domain is the real number. So first I need to move my 3 over. I've got x squared plus 4x plus 3 is less than 0, and I'm going to factor this portion of it. So I have x plus 3 times x plus 1 is how we factor that, and that's all going to be less than 0. So remember, we kind of had to logically think through this. If I have a product of two quantities and they're supposed to be less than 0 or negative, that means the first one can be positive and the second one is negative, or the first one is negative and the second one is positive. So we're just going to write down that fact and start to simplify. So the first one can be positive and the second one can be negative in order to get a quantity that's less than 0. Or the first one can be negative and the second one can be positive. So let's take a look at how we start to simplify this. If the symbols are going in opposite directions, we need to verify that it is possible. Before we can do that, I need to isolate x. So I'm going to have x is greater than -3 and x is less than -1, or x is less than -3 and x is greater than -1. So let's take a look at this, for example. I can't have a number that is simultaneously greater than -1 and less than -3. So what we can do is cancel that possibility out. And all we're left with is this. Can I find a number that's greater than -3 and less than -1? Indeed, this one is possible. So this is the only portion that we're going to graph. So I have -3 on my number line, -1. And again, we're doing real numbers. Because there's no equal bar, I can only put an open dot on the endpoints, and everything in the middle satisfies this inequality here. So for those of you who are able to graph that correctly, nice job. If you didn't, go back and watch this section to make sure you know how to do it, and come see me in my live hours if you have any additional questions. Good luck on the homework today, guys.